ADISRA has unveiled version 4.1 of its ADISRA SmartView Scada and HMI software. In this video, we will dive into the key new features of ADISRA SmartView 4.1. We will begin with the new ADISRA SmartView Launcher. The ADISRA SmartView Launcher provides quick access and additional information about the different modules the user can execute. It acts as a central hub for various resources and information related to the software. This includes links to the ADISRA's website with support information, documentation, knowledge base articles, and more. You can create a new project or open one from the recently used project list all through a simple menu. This release also allows applications to run on various Linux distributions, offering most of the functionalities available in a Windows environment. This new feature enables customers to integrate ADISRA SmartView runtime with different Linux-based hardware, allowing communication with various PLCs and databases while analyzing the data, making decisions. Additionally, it supports data analysis, decision-making, and management of web and viewer client connections. This broadened compatibility ensures that our software delivers optimal performance in an expanded array of environments. Linux is a versatile and robust operating system that lends itself to edge computing perfectly. Its open-source nature and other Linux features such as adaptability, scalability, and security make Linux a great candidate for an operating system that powers edge computing systems. In industrial settings, Linux-based edge devices can efficiently process data from sensors, actuators, and programmable logic controllers. This enhances real-time decision-making, operational efficiency, and safety in the rapidly evolving IoT landscape. In a distributed IoT application, sensors and equipment deployed across a wide area connect to one of many edge gateways throughout the entire network. Each edge gateway acts as a data concentrator, protocol converter, and data preprocessing device for all the sensors and equipment that connect to it. The edge gateway then transmits all of the preprocessed information from the edge system, comprised of the gateway and connected sensors and equipment, to a public or private cloud for big data analysis. Typical distributed IoT applications include smart cities, such as smart meters and street lighting management, renewable energy, such as solar or wind farm monitoring, and oil and gas. Another hot topic is the rule-based system. Rule-based systems are a specific category of expert systems that can be developed by utilizing expert knowledge or learning from actual data. A rule-based system generally comprises a series of if-then rules that can fulfill various functions, such as providing decision support or facilitating predictive decision-making in practical applications. One significant challenge in this field is developing these systems using expert knowledge and a vast amount of data. The human-machine interface serves as the essential connection between a human operator and an industrial controller or a process control system, such as a programmable logic controller. Its primary role is to provide a real-time view of the system's operations, displaying critical data and enabling the operator to execute commands. As a connected device, the HMI generates and delivers vast quantities of data. This data is utilized by rule-based systems to start making intelligent decisions. The ability of the HMI to gather and convey data lays the groundwork for merging real data with machine learning and rule-based systems, an integration that begins to replicate common sense in decision-making processes. ADISRA SmartView enhances this by integrating HMI with a rule-based system, creating a framework that advances industrial applications with intelligence. For instance, it could be used to diagnose energy distribution in a plant, ensuring an intelligent balance between the supply and demand of gases used as primary energy sources. The system incorporates rules designed to emulate operators' actions at the energy center. ADISRA SmartView, with its rule-based system, draws conclusions through inference from the rules using data collected from sensors or gauges installed at the plant. This approach not only enhances efficiency but also improves the responsiveness and adaptability of the system to changing operational conditions. ADISRA SmartView rule-based system provides an intuitive approach to rule-based creation, aiding users in building a knowledge base for decision-making. Finally, this video will also show usability enhancements, such as a new date-time picker object to facilitate user interaction with date and time selection, updates on the tags group, which provides easy-to-access tools, script validation on split mode, and detailed usability information for expression boxes. Let's explore the demo applications to see what's new in ADISRA SmartView 4.1.0.0. The launcher is an intuitive graphical tool that provides quick access to different modules of ADISRA SmartView. Users can use the launcher to create new projects or to open existing projects. The development environment is a contemporary ribbon-based Windows interface, offering a cohesive and user-friendly project development environment that enables seamless access to graphics, alarms, trends, recipes, reports, scripting, and more. The runtime process integrates all the development modules into a unified application and distributes the data to various clients, including local, web, and mobile viewers. The Viewer module enables users to access, view, and interact with data or content. ADISRA SmartView viewers present the information processed by the application and can be displayed locally on desktops, HMIs, servers, web browsers, or mobile devices. The Redundancy tab provides information about utilizing redundancy. For critical applications where data is essential, ADISRA SmartView offers comprehensive system redundancy. The Licensing tab lets you check, register, and validate your license. ADISRA SmartView offers both hard key and soft key licensing options. Within the Licensing tab is a straightforward button to generate a site code, which should be sent to ADISRA to receive a site key. It is important to note that the development and runtime licenses must be the same version. The Data Watcher tab offers a runtime debugging tool for monitoring and controlling tag values. The Remote Tools tab facilitates connecting to a remote station, allowing you to easily download, monitor, and debug applications residing remotely. Last but not least, the Assistance tab provides valuable information about ADISRA SmartView, including technical documentation, access to the video library, and the knowledge base. It also includes details on how to contact us at no charge. We are always here to support you throughout your application journey. The next feature we are going to showcase is the Linux runtime. Windows users can utilize the remote management tool to connect to a Linux machine, transfer applications, run and stop the runtime server, manage licenses, and debug using the logs. To establish a connection between the remote management tool on a Windows machine and the Linux installation, the user must first run a service on the target machine. Once connected, the user can transfer the current application to the target machine, download it at any time, or transfer web pages to the Linux environment. The License tab allows users to register licenses on the target machine and check the active license. After executing the runtime process on the Linux machine, the users can connect to it from client viewers or web viewers. With the new Linux support, ADISRA SmartView software opens up new deployment options in industrial environments. If you have any questions, please do not hesitate to contact our team. The new rule-based system module added to ADISRA SmartView version 4.1.0.0 supports forward-chaining reasoning, introducing a powerful inference engine that mimics human knowledge based on predefined rules and facts. Forward chaining starts with known facts and applies rules to infer new facts until a goal is reached. Rule-based systems in AI require a set of facts or source of data, and a set of rules for manipulating that data. These rules are sometimes referred to as if statements, as they tend to follow the line of if X happens then do Y. These statements define rules that dictate the system's behavior under certain conditions. These rules are often called production rules or simply rules. You can create decision-making rules across multiple domains, organized into sets representing specific knowledge bases. These facts can be linked to various data sources such as database tables, CSV files, or application tags. The rule editor features an intuitive interface with tools for writing combined conditions based on facts or application tags, and for creating rule actions. Actions may include setting tag values, sending emails, triggering alarm events, or executing scripts to enhance the knowledge base. During execution, the inference engine evaluates rules and activates corresponding actions when all conditions are met. In this example, the conveyor starts when no security sensors are activated. However, if any sensor is activated, the conveyor stops for security reasons. The rule-based system can also be used to control simple tasks. Let's create 2 rules to control valve flow. It might be an alternative to the text box limits, which you will still see in this video, but using rules instead. To begin with, let's create 3 tags. The valve tag and the others representing the low limit and the high limit of the valve. Then we will create the first rule to check the valve's low limit. Our condition is whenever the value of the valve is lower than the specified limit, the rule will be activated and execute the action. In the action, we want to adjust the valve's value to the lower limit. To achieve that, we will use the setTag action type. This could also be achieved using the script action. As soon as the first rule is saved, we can use it as a template for the second rule, which will be very similar, except that we will now validate the high limit of the valve. Let's edit the condition to verify the max limit instead. The action also must be changed to adjust the valve based on its higher limit. Now let's create a graphic to test and demonstrate the application. We just need to add text boxes displaying the valve tag and its limits. The initial value of the tags is 0, so initially the graphic will display all of the tags with 0 values. During execution, we will change the limits and the valve to test the rules. With everything ready, we can set the new graphic as startup screen and run the application. When the application loads, we can see the valve is still at 0. Let's set a max value as 100 and a min value as 12. As soon as we change the min value, the rule that validates the min limit triggers and sets the valve value to 12, which is the min limit. We can change the value of the tag inside the range, but if we trespass the higher limit, the valve will also be corrected to match the max limit. Let us now review some of the other enhancements and improvements to the current functionality of ADISRA SmartView. Another new feature being added to version 4.1.0.0 is the new datetime picker object, which is being added to the advanced objects list. This new object will help users build applications more easily when manipulating dates and times. It allows the user to link a datetime tag and get or set the selected date and time depending on the logic. It can also be changed to a date picker, in case the time is not needed in the application. At runtime, the datetime picker provides a nice interface facilitating the date and time selection and display. The data grid object received an upgrade to allow customizing the column alignments individually. The user can now also define different alignments on the header of the table. The next upgrade on the data grid object is to configure word wrap on the header and on the content and to allow multi-selection during execution. The user can now enable multi-selection and get selected rows using a new function available in the data grid object. The text box has been enhanced to enable input validation for numeric values during runtime. Users can now manually set a predefined numeric range for validation when entering new values into a variable. If the new value falls outside this range, text box will display an error message and the new value will not be applied to the variable. This enhancement ensures that incorrect inputs are prevented from entering the system, increasing its security and reliability. In this example, we will demonstrate a text box with a fixed range and a text box with a tag limit. Both top text boxes display the same text value, but the fixed range text box is limited from 0 to 50, while the example on the right uses a tag range from minimum to maximum. We will now switch to runtime mode using the local viewers. When the tag value on the fixed range side is outside the range, a pop-up message will appear, indicating that the value is outside the higher limit. On the tag limit side, you will notice that the upper limit has changed to 200 to accommodate the maximum tag range. This enhancement allows the system to adapt to dynamic conditions and varying requirements, while also saving time and reducing downtime by enabling on-the-fly changes to variable limits. Thanks for watching until the end. Visit the ADISRA website for more information or contact the info@adisra.com or the sales team.